Now let's look at the quotient rule. The quotient rule states if I have the derivative of f divided by g, then that's going to equal g times the derivative of f minus f times the derivative of g divided by g squared. And of course, g can never equal 0. Now this is a fairly cumbersome proof, and I'm going to want you to do it as homework. Let me show you a method that I use that works quite well with these. The first thing I do is I identify my top function and my bottom function. So f is 5x minus 2, and g is x squared plus 1. I write my function, and then I come over here and I write the derivative. Now, to remember the function, it's this, g, f prime, and it's plus because it's going upwards. So this is x squared plus 1 times 5. And then it's minus, you always cross, minus 5x minus 2 times 2x. And then, of course, it's all over the closest one there, which is closest to my y prime, x squared plus 1 squared. I strongly recommend you do write the definition of the limit every time, especially when you're starting, or the definition of the quotient rule there. All right, now I'm going to expand this out a little bit. So this is 5x squared plus 5 minus, this is 5 times 2 is 10x squared plus 4x divided by x plus 1 squared. So now you do need to simplify, put it in order. So my highest power is negative 5x squared plus 4x plus 5 divided by x squared plus 1 quantity squared. Now suppose I wanted to find an equation of a tangent to a graph, and they give me this. Now you can adjust your formula a little bit. So if I tell you that f is 3 minus 1 over x divided by x plus 5, let's simplify this. There's no need to make our lives too terribly hard. So the first thing I'm going to do is get a common denominator in my numerator. All right. So this is 3x minus 1 divided by x times 1 over x plus 1. And there's nothing that's going to simplify nicely at all. Oh, it's not plus 1, it's plus 5. Goodness. Yeah, don't rewrite your problem. So when I rewrite it now, this is 3x minus 1 divided by x squared plus 5x. Okay, now I write my top function, and because this is f, I'm going to use something else. Let's call this h, is 3x minus 1, and g is x squared plus 5x. H prime is 3, g prime is 2x plus 5. So f prime is, now go up and it's plus x squared plus 5, ooh, x, I don't know what's wrong with my computer, times 3, and then it's going to be minus, because we're going down, 3x minus 1 times 2x plus 5, and the whole thing is divided by x squared plus 5x squared. And now to simplify this, you multiply it out, and this becomes negative 3x squared plus 2x plus 5 over, oh, pin here, x squared plus 5x quantity squared. And that looks terrible, So let me adjust my pad here and rewrite it. So this is equal to negative 3x squared plus 2x plus 5 divided by x squared plus 5x quantity squared. But I'm not done. What is f prime at negative 1? Well, f prime of negative 1 is negative 3 minus 2 plus 5 divided by 1 minus 5 squared. So I get, oh my goodness, this is 0. So the equation of the line has a 0 slope. All right, so what is y minus 1 is 0, x plus 1, so the line is y equals 1. For this problem, we can just use, we can just distribute this. If I take the derivative of this, this is 2x plus 3 divided by 6. You see, I don't have to do anything fancy there. For this one, y prime is 5/8 times 4x cubed. I do need to simplify this. 5/2 x cubed. Now, this one, I can do a little bit of a cheat. I'm going to rewrite this as negative 3x. I'm going to factor in x out of here. If I factor an x out, that's the 3, so I'm going to be left with 3 minus 2x. So I'm going to simplify this first. So this is negative 3/7 times 3 minus 2x. Now, y prime is negative 3/7 times negative 2. So it is 6/7.